Okay, this podcast will talk you through how to do your calculations of your equilibrium concentrations for iron 3 ion and the thiocyanate ion for your equilibrium lab. What you see here is the equation that we're working with throughout the lab, right here. And you'll also see that I set up an ICE table, which we also have called BCA tables in the past. And down here is this is the data that I took from the procedure on the concentration and volume of iron 3 nitrate that you put into test tube 1. So the I in ICE table stands for initial. So I do need to calculate the initial concentrations of iron 3. You can see how to do this in your pre-lab problems because you did something similar in that one. So I had 3 milliliters of 0.002 molar iron nitrate. So to calculate the initial concentration, I had 0.0020 moles in every 1 liter. I didn't have a liter. I had 0.00300 liters. How many moles was that? If you calculate that out, you get, what is that? It's going to be 6.00 times 10 to the negative 6th. And then if you look at the total volume in the test tube, because you added the 3 mils of iron nitrate, you added 2 mils of potassium thiocyanate, and then you had 5 mils of water. So that totals 10 milliliters. So if this is my number of moles, and I had 10 milliliters, I would divide that by 0.010 to get the initial concentration of 6.0 times 10 to the negative 4th. So this is my initial concentration of iron 3 nitrate. I'm going to go ahead and plug this value in to my ICE table. And I'm going to write it right here. 6.00 times 10 to the negative 4th. I would do the same thing for SCN. The volume of SCN is different. It was 2 milliliters instead of 3. So if you follow the same procedure as I did for iron, when you calculate out the thiocyanate, you get 0.4 or 4.00 times 10 to the negative 4th. And you should recall that we did not add any of this ion in the initial test tube. This was not present until we added the other two, in which case these two would react to make this. But initially this is 0. So you ask yourself, which way is this going to shift? Or in which way will this reaction progress? Well, since there's 0 of this to begin with, the reaction will shift to make the reaction will shift in order to make that product. So it's going to move toward the right. Okay, so that means that this will increase by some value x. We don't know what it is yet. And then if you go back and look, this is a 1:1:1 ratio. So if this is increasing by x, that means that both of these will decrease by x. So then you can go back to the data that you collected, and you can look at your graph to determine the concentration of FeSCN. Since this is a colored complex, we were using the colorimeter, and it was measuring the absorbance of the light passing through this colored solution. The concentration of the FeSCN plus 2 ion can be determined either directly from the data on the colorimeter or by plugging in the values that you got into the line of best fit and solving. So the data that I have, it shows my concentration of FeSCN to be 2.88 times 10 to the negative 5th. So look at what the ICE table is showing us. We had 0 to begin with, we added some value x, and we ended up with this amount. Well, that tells me that this value right here is equal to x. So if you go back, the equilibrium concentration of Fe ion is going to be 6.00 times 10 to the 4th minus x. And SCN is going to be 4.00 times 10 to the negative 4th minus x. Well, this is x. This is x. So if you subtract these, if you actually subtract them, you'll get 5.7 times 10 to the negative fourth and 3.7 times 10 to the negative fourth. This is the data that I have. Yours is going to be different. But this is how you solve to get the equilibrium concentrations of the Fe ion, the SCN ion. This is for test tube 1.